Welcome to Amped Up, Utility Insights, Trends and Challenges. I'm your host, Melissa Parvis, CEO of Athena, a consultancy and workforce solutions provider operating in the utility sector. In this podcast, we explore the ever-changing landscape of US electric utilities with great minds and insightful conversations.
Thank you for joining me today. I recently read a very interesting article about the major disconnect between network security and engineering stakeholders within critical infrastructure organizations, and how it's the biggest threat to critical infrastructure that nobody talks about. I found the article so interesting, I reached out to the author, Joe Weiss, who joins us today to expand on his thoughts. Joe is a nuclear engineer who spent 15 years at the Electrical Power Research Institute, or EPRI for short. During his time at EPRI, he started the Control Systems Cybersecurity Program for the electric utility industry back in the year 2000. Joe has extensive experience working directly with utilities and understanding the challenges they face in securing their operational technology environments. After leaving EPRI, Joe continued to research and write about the gaps in how utilities approach cybersecurity, and in particular, the disconnect between IT security teams and the engineers responsible for the actual grid environment. Thank you so much for joining us today, Joe.
Thank you very much for reaching out and having me.
Of course. So, how long have you been talking about this subject?
Funny part is the issue of the disconnect between IT and engineering predates Y2K. So we were talking about this subject probably in the mid 90s. And it started because there was this focus, as more and more of the enterprise resource planning ERP projects were going on. SAP, uh, Oracle, etc.
Yeah.
These were very, very, very large projects. These were like $500 million projects or so. And so there would be, scheduled meetings with the boards, the different companies to discuss the status. Whereas on the control system side, even when you were doing a distributed control system upgrade or whatever, it would be maybe, say, 10 to 20, maybe even $50 million. And often the board wouldn't even really know about it. So you had this disconnect in terms of, awareness of what was going on, resources being allocated, etc. So that was going on. There was also this tendency that in the mid 90s or so, mid to late 90s, Windows was starting to creep into the operational side of the world because for the first time there was the ability to get this really important information out to the rest of the corporation. And they figured, well, Windows and TCP/IP, etc., would be the vehicle for doing that. So what I'm saying is the historical background is this issue that's very, very big in the security world actually started long before we were thinking about security. It was because of the technology being able to get this critical information off of these systems and outside, if you will, the control room off to the rest of the organization. So it started all the way back then.
And why is it, apart from the obvious reasons, why is it so important to talk about?
Well, because if you're an industrial or a manufacturer, the most important information you have is about what you're making.
Mm.
Okay? How much is it costing you to make? How soon can you get it done?
Mm.
And what's affecting us to this day is that this most important information is still secondary to what IT thinks is important to them. So there is this really big disconnect that continues to this day. You would think somebody who manufactures widgets, the most important thing they would want to know is how many widgets am I making and how much are they costing me? Only that's kind of secondary to IT's metrics of, is my network up, or, what's going on with my firewalls? And we have to figure out how to get that flipped.
And particularly in the instance of utilities, how does that manifest?
Well, it's for the production, in other words, in your generation, your transmission, and your distribution. So you're basically asking, for example, how much does it cost to produce, a kilowatt or a megawatt of electricity? Gee, that should be really important. The next thing is, how much is it costing me to maintain that series of electric substations that's allowing me to get where the power is produced all the way to the end user? And the other is, how reliable is it? Are there any blackouts or brownouts? Are there power quality issues? Especially with more and more electronics. Those are the things you would think would be most important to an electric utility. And cyber affects all of those, but cyber's not the leader. Cyber is simply a piece to that.
So why do you think people aren't talking about it?
Different way of phrasing it. The electric grid was identified as one of the greatest engineering inventions of the 20th century. Not networks, the electric grid. Okay? That's engineering. Okay? The power grid networks are networks. They're no different in the power grid than they would be anywhere else. But unfortunately, like I say, things are flipped. Instead of worrying about, are the lights staying on, they're worried about who's trying to hack my network. And it turns out, even if your network is hacked, you can still keep the lights on. You won't be as efficient, and you may have to send people out to the substations or whatever that were unmanned before. But the point is, you can do that. The Ukrainians ran their grid for about 6 to 8 months without any networks after the 2015 Russian cyber attack against the Ukrainian power grid. Why? They couldn't trust the network.
So how did, maybe my ignorance is going to show here, but I don't understand how that works. Would you mind going into a bit more detail of how that's even possible?
The point being that if you think about it, we were running power grids for the past 100 years. Okay.
Right.
The same way you were running factories and everything else. What these networks did, and this was part of what I was doing at EPRI, long before I got into security, is we were trying to improve the automation of these processes because of two things. One, it made you more efficient. The other is it allowed you to lower costs. And unfortunately, the lower costs were because you didn't need as much manpower. But the point being, and again, this is what people forget. We were running electric grids and power plants and refineries and, auto manufacturing and everything else for 50 to 100 years before, Windows and Internet protocols came along.
Mm.
But people forget that. And it's, you talk to anybody in IT, it's like, well, if you don't have that, you can't run. That's not true. You just have to do it manually.
So, in that understanding that in that context, why do you think nobody's or very few people, apart from yourself, are talking about it?
Because what happened, I'll go back to, if you will, until 2006. That's when Gartner put out their paper on defining the term OT, operational technology.
Mm.
Until that time, you were either engineering or you were IT. Okay. And IT was, in a funny sense, limited as to what they could do or say. Okay. When you went into a substation, a power plant, a refinery, a water system, the owners were the engineers. Well, because, following 9/11, when cyber became national security, before 9/11, it was not. Okay. And then with the advent of the term OT, the engineers were basically severed from the world of cybersecurity.
Mm.
Okay. Their function was moved to the network security organizations, whether it was called IT or OT. And the board looked at the word cybersecurity or cyber as an IT function. And as a result of that, the engineers were basically kept out. Now, the engineers, on the other hand, didn't view this as critical to being able to operate their facilities. So they didn't fight it.
Mm.
They weren't in the room. They weren't fighting to get into the room. So you had this dynamic where the engineers, and by the way, I should go back to another point. The whole issue of cybersecurity of critical infrastructure, including the electric grid, started in June 1998 when President Bill Clinton signed Presidential Decision Directive 63, PDD 63. And it stated that within 5 years, all of the critical infrastructures were to be cyber secure. That meant by 2003. We're 22 years later, and we don't have any fully secure systems anywhere.
Mm.
Point is, I know I can speak for myself. I was in 1998, I was running the fossil plant instrumentation controls program. And I had the head of IT from EPRI come to my office and ask me, would you please address cybersecurity? And I'm going, well, what does that have to do with running a power plant? My view, and unfortunately most engineers' view to this day, is that cybersecurity is email. Or it's, my credit card or, social security number, whatever, the protection of it. And the concept that cybersecurity could affect a pump, a valve, a motor, a turbine, a relay or whatever, was simply not thought about.
And this was what year?
When I first had that happen to me was in 1998.
Right.
Okay. When we started the EPRI, control system cyber program, we really didn't much of a problem it really was. We started it for a really different reason. I was the technical manager of the Y2K program for the electric utilities, the embedded systems. And one thing happened with Y2K that has not happened to cyber, and it's, again, hurt us, is with Y2K, officers and directors were personally liable. Not as a corporation, personally. So what you had for the first and only time was all of the silos between all of the organizations come down. It's amazing what happens when you become personally liable. When we started the EPRI program, when it started, like I say, quote unquote, 1201, 2000, when Y2K ended, we didn't know there was a problem. We just knew we finally had people talking to each other. And we made the erroneous assumption that would keep going. Only what happened was this law that made officers and directors personally liable sunsetted or ended at 11:59 a.m. 1999. So in 2000, it was no longer there. We didn't realize that. Okay. So again, when we first started, it was an engineering program. It was not a network program. But within a year or so, I remember we had this meeting at EPRI, and it was like a teenage dance. You had all of the engineers on one side of the room. You had all of the net IT people on the other side of the room. Even from the same utilities, the engineers were on one side, IT was on the other. And then one of the people from one of the utilities stood up and said, IT is taking this over.
For their utility or nationally?
Well, he was talking about within, that meeting, but it really spread not nationally, but internationally.
Mm.
You'll find the same thing in the UK, in Europe, in Japan, in most places in the Middle East, all over.
Yeah.
Because once the model is set, that's what people do.
Yeah. Yeah. That makes sense.
So, anyways, culturally, we've been at odds since even before 2000. And the problem is getting worse, not better.
So let's delve a little bit deeper into today then. What do you think, how does it manifest, and what do you think the knock-on effects are?
Well, what's happened is, and I think people will take a knee-jerk reaction and say, Joe, you're wrong. It's, things are good. What is happening is cyber has made its way to the boardroom. Okay. And the start was really not at all having anything to do with OT. It was all of these IT networks attacks. And companies were being pushed to have somebody on the board who knew something about cyber. But as an example, there was a large electric and gas and electric utility. I mean, this is a utility that had gas pipelines, had, electric transmission, distribution, fossil plants. It had a nuclear plant.
Okay. Big.
All of this. Okay. So who did they get to be on the board that would be representing cyber?
I don't know. Who?
An executive from Comcast.
Okay.
Now, what does Comcast know about pipelines or power plants?
Yeah. Right. Yeah.
Okay. But
But they had a cybersecurity background.
that's the
Oh,
point.
yeah.
They were able to check the box that, yes, we have cyber. Well, now OT has made its way into the boardroom, and it's really one particular company that's really been able to push this. But the problem is that push, even though it says OT, is nothing but the OT networks. Absolutely nothing to do with any pump, valve, turbine, relay, transformer. It is 100% the Internet Protocol networks. So, are we making progress? Yes and no. The box can be checked. Not only do we have cyber, but we've got OT cyber. But are we protecting the actual facilities? No. And what's worse is in 2000, we kind of knew we weren't doing things. Now it's so much worse because now there's this perception that we've got everything covered.
Mm.
So I tell people we are actually further behind today than we were in 2000. Because in 2000, we weren't doing things because we didn't know.
Mm.
Now we're not doing things because we don't want to look at them.
And that's because there's this disconnect between the engineers actually
Yes.
performing, okay, and then the network security. So let's talk a little bit about what the implications are, where the areas are for vulnerabilities, where you think that the low-hanging fruit, as it were, could be to ameliorate the situation.
Well, you start back with Stuxnet. Stuxnet changed everything for a different reason.
Sorry, what's Stuxnet?
Stuxnet was the destruction of the centrifuges in Iran.
Okay.
Okay.
You're talking
And
about this is the nuclear program in Iran?
yes,
Okay.
yes, in 2009, 10 timeframe.
Mm.
Prior to that time, you were able to easily or distinguish between something being a glitch and something being a cyber attack. Okay. And so you could say this was a control system incident versus this was a control system cyber incident. What Stuxnet demonstrated is a sophisticated attacker could make a cyber attack look like an equipment malfunction.
Mm.
And all of a sudden, everything changed. Only the network people to this day refuse to acknowledge or address that. What made Stuxnet successful, this is another thing that's really, really fascinating. It is about the only time where engineering, cybersecurity, and physical security work together seamlessly. The only time. And that was to go out and break things. They have never seamlessly worked together. I'm using the word never. There's all going to be an exception somewhere. But they have never seamlessly worked together to defend any facility.
Mm.
Isn't that a damning statement?
It is. Who do you think would be critical of that statement? Who do you think would disagree with that?
Anybody on the cyber side?
I was going to say, it seems like your preference or you lean towards backing up the engineers in this instance.
Yes.
What do you
It's
think?
it's I go back and say this. If you were going to get a heart transplant,
Mm.
who do you want doing the operation?
A heart
The heart
surgeon.
surgeon
Yeah.
or the network people who network the operating room?
Okay.
That's a brain dead, simple statement, isn't it?
Yeah, it
Until you
is.
talk about where we are. And then all of a sudden, it's the network people who are telling engineers what should be done with their systems. This is insane. Absolutely insane. The only thing that makes Macy's different than Con Ed has transformers and relays, and they used to have turbines and all the rest. The networks are the same.
I mean, I wouldn't know enough to know that. Is that really true? That surprises me.
Why? It's an internet protocol network.
Yeah.
What may be contained in the packets is different. Here's another thing. Years ago, the executives in utilities were engineers. They
All of
worked their
them.
up, through through the system. Now, if you look at many utilities, again, this is not all, but many, these are people that came up the financial chain. So they're not engineers. They don't understand all of the intricacies of, by the way, that's not just utilities. You'll find that all over. That more and more of the executives are coming from the financial rather than the technical side.
Yeah, I mean that makes sense, doesn't it? From a business perspective that has a duty to its shareholders to make a profit. Yeah, so and there are exceptions, but most engineers probably aren't as commercially savvy as people from a financial background. So it makes
Yeah,
sense.
yeah, and their focus and their their like or attention or however you want to phrase it is from the technical side. Now, again, there are always exceptions, and there are some really, really good financial people who are engineers. There are some good financial people who have not only a good understanding, but also a really good relationship with their top technical people. But those aren't necessarily the rule.
Mm, I see.
So, so you look at this, and control system cyber is a technical issue. You really need to understand, in I'll say, an industrial or a manufacturing facility, it is a very sophisticated system of system design.
Mm,
So you may have, say, an Emerson sensor, a Rockwell controller, a Siemens another Siemens controller from some sort, a Honeywell distributed control system. All of these are in this system. And they're all doing different functions needing to be coordinated. It's very complex. And none of this was ever designed with security in mind. So when you start tweaking it for security, because, gee, this seems like a logical thing to do if you're in security, you may cause these really big impacts because the system wasn't designed for that.
mm. I've just thought, I've done a lot of, I've only been in the industry for 10 years, so I don't know whether this is a relatively new thing, but I've recruited a lot for people of an electrical background, technical electrical background, so that have an electrical engineering degree. They've maybe worked as an engineer within transmission or distribution or substations, and then they've moved into SCADA and operational technology, DMS
Yes,
systems.
yes.
Are those people not the bridge between the two areas?
they could and should be. One of the funny parts about what you said is SCADA was the one area that, depending on the time of day, was either part of the engineering organization or part of the IT organization. Because a SCADA system is really this big, or an energy management system, really, SCADA EMS, is really a big IT system.
Yeah.
The SCADA system is not the remote terminal units in the substation. It's not the relays or the transformer. It's this, what's called an engineering master station. So it's this big Windows system. So you could easily make an argument that it's engineering or that it's IT.
Yeah.
What you can't make the argument about is the transformers and the relays and the turbines and the pumps and the valves. That's always going to be engineering.
Mm.
SCADA is kind of this funny animal that can kind of be either. And then you have all of the data warehouses and everything else that's really very much more, the IT or business.
Mm.
So the point being, yes, you have that occurring. I'll give you a funny story. I ended up having to make a trip overseas because the SCADA organization used to be in engineering. And they had a reorganization, and SCADA was brought under IT. And then they outsourced IT. And then the outsourced company outsourced security.
Mm.
So when engineering went and asked, who do I talk to? They didn't even know who to tell them. Now, this is the security of your SCADA system.
Mm.
So I ended up having to fly, in this case it was overseas, to go in with the engineering management to senior management and say, here's why you got to bring this back. This was kind of the, one of the extreme cases. If the SCADA organization would have stayed within IT and IT would have stayed within the organization, not be outsourced, and engineering would have had a name and a face to go to.
So, do you see those individuals with that background in both technical component engineering for a utility and the SCADA, the EMS background? Do you see those people being the bridge to the gap between
Yes,
these two departments? Okay.
if, like I say, there aren't a lot of them.
Mm. I
But
have seen more and more in recent years.
the
Um,
there is a move. Okay, now part of the issue is a lot of the people who are doing this are people who came from quote unquote the SCADA side or the DCS, distributed control system side,
mm,
rather than actual plant operations or plant maintenance. So there were really computer people moving from one, computer aspect to another. What we need, and there are people, there just aren't very many, who are really, really knowledgeable about plant operations and maintenance or substation operations and maintenance, who make their way over in toward IT. That would be the ideal.
I see. What do you think about the future? I don't know whether you know much about LLMs or all of this AI technology that's come out in the last couple of years, and some concerns that have been arising about their ability to perform brute force attacking on critical infrastructure. Just do lots and lots and lots of repetitive tasks that require limited to minimal thought and creative intention, but ultimately do it many, many, many times over. And something that a human just wouldn't have the time to do. But
Well,
yeah.
that's been going on for a long time,
Mm-hmm.
which is why the encryption standards keep getting, moved up and up and up, because that brute force, the computer technology, okay, and one of the real concerns is quantum,
Yeah, I've heard about
okay,
this.
plus and minus, as well as AI. You think about what just went on yesterday. The thing about I wanted to bring this up because I also had a number of people send me some stuff from Chat GPT and say, "Okay, what do you think?" They're saying, it's like, how would you hack a power plant or whatever? And I look at that and I'm going, all this is this phenomenally powerful computer able to get a hold of pretty much most everything that's been written.
Yeah.
Okay. Now, in my world, I hate to phrase it this way, but much of what's been written is wrong.
What do you mean?
It's simply not right, in that much of what's been written has been written by people who come out of IT. And so they write things as if the control systems were just another IT system.
Sorry, what are you referring to? What do you mean writing?
Like on LinkedIn, or like I say, even within some of the AI um, output, you say, tell me all of the ways the control system can be hacked.
Okay, I see.
And I'm looking at some of this stuff and I'm going, that's not true. But it's exactly what I've read on LinkedIn. I've had things about people sending me, hey, here's what AI says about Aurora, the Aurora vulnerability. And I look at this and I'm going, no,
Mm.
but I've seen it all before. It's just AI gives you the opportunity to grab it all together and synthesize. There's a very old saying, garbage in, garbage out. And AI can do it a whole lot faster than we can ever do it.
Mm.
AI doesn't have the ability yet to distinguish between technical fact or fiction.
I see.
And people take it, hey, it's AI, it must be right. And this isn't just in our world. I'm saying,
Yeah, I mean, we've all seen AI be very confident about things that are very clearly wrong.
yes.
Yeah. I saw
So,
this was a couple of years ago. I saw a post once where somebody did a very simple math problem. It was like 2 + 2 - 3 or
yes,
something. And it kept saying the wrong number, the wrong number. And it was just
yes,
so adamant that the number was right.
absolutely.
And then eventually it was like, oh yeah, I am wrong. When the
Yeah, but
person,
the issue
yeah,
is, and you're going to have people believe it because, it's the official, it was on the internet.
yeah. Okay. So having said that, do you see no threat with AI, or what? How would AI have to? What would it have to look like to be threatening in this instance?
Like I say, AI can be very threatening for two reasons. Okay, and let me rephrase it too.
Go
AI
on.
can be very, 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 very useful. Okay. The flip side is AI can be very, very threatening because number one, like you just said, 2 plus 2 minus 3, and it gives you the wrong number. But it's coming from it, so you use it. The other is that somebody, intentionally uses AI to quote unquote learn what to do so that they can cause harm. Whereas without the AI, they wouldn't be
Right.
smart enough or competent enough to do it.
So another analogy for that would be if somebody wants to make a bomb, they just go
Yes,
online and type in, how do I make a bomb?
yes,
Yeah, I see.
yes. So there's one of the things I found early on. Engineers in general look at technology as a single-edged sword.
Mm.
It's only for the good. The bad guys look at technology as a double-edged sword. Yes, it can give you this good, but look what else I can do with it.
Mm.
And oftentimes, I know I was in this boat, I never considered how could somebody misuse something that was designed for good.
I mean, there's a lot of ways of tricking the AI. For example, if you put something into it, you ask it a question or you ask it to do something that's a little bit politically incorrect, it'll say, I'm not going to do this. But there's some very simple ways to trick it into doing it anyway.
It's
Yeah.
just we have a faster, more automated way of hurting ourselves.
I see.
But it's just, you have to better know and understand what it is you're doing and does what you're being given make any sense? You don't need to know all of the mathematics behind it, but you do have to know a little bit about, hey, if I raise the pressure too much, can I really cause a problem? If I keep lowering the temperature, am I going to have a problem?
So
They have
I'm
some.
I'm I'm making a bit of a leap here, but do you mean by that knowing that if changes are made to a system, what the engineering implications are
Yes,
of those changes? Right, I see.
yes,
Okay.
and
So not just understanding, oh, someone has my email password, but
yes,
someone has access to a system, and if they do XYZ, then that could cause ABC, which is
yes.
very detrimental. Right, I see.
I've been asked to write something for somebody, and the first question was the challenges for cyber risk in industrial environment. Well, if you're in an industrial environment, I mean, think about this:
Mm.
the 2003 Northeast outage. Gee, it was an outage, quote unquote, an electrical problem. Okay,
Mm.
that electrical problem led to I don't know how many water systems failing. You know,
Okay.
all of the lights went out. Um, I think there were, forget, 9 or 11 nuclear plants shut down. I mean, this was a tree falling, on a power line and a SCADA system not operating correctly. That affected 50 million people. Okay. Um, these are, it tripped off, God knows how many refineries and chemical plants and everything else. This is, and it's not just, like I say, electric. There was a water issue earlier this year. I won't mention where, but not only did it prevent all drinking water, there was a boil water order for 5 days. It turns out the state legislature in that state wasn't able to meet for those 5 days because there was no water. How about that? Who'd have ever
Wow.
thought of that?
So that's obviously emergency management didn't even consider. Is that what you're saying? They didn't even consider
Who'd
in
have
the event.
thought that a
Yeah.
water problem could have somehow propagated to the fact that the state legislature couldn't even meet?
Yeah. Yeah. And there's probably hundreds of thousands of potential
It's
issues like that could occur that no one could really foresee.
the point is the, if you will, industrial infrastructure is so intertwined with everything we do.
Yeah. So, what if you, I don't know what position this would be in the government, that you were head of the Department of Energy and you had to enact regulation over all electric, water, gas, critical infrastructure, utilities
Mm-hmm.
all around the country, what would you do to improve the situation?
I would make sure that all of the control system devices were to be made secure. And if not, that there would be technology to let you know whether it was or not. I'm hoping, when I put this out, will the next administration finally address control system cyber? None of them have.
Mm. So, what measurable things do you think need to be put in place?
There are technologies available that can get us some of the way there. There are technologies that can get us a lot further. There's, but these are engineering problems. They require engineering solutions. They do not require network solutions. The
Right,
network is a conduit, if you will. It's all about what goes into the pipe, not the pipe.
right.
And we're
So,
not addressing what goes into the pipe.
right. What are the names of some of those technologies and how can they
And
help?
I'm not gonna go in, but I've I'll give you an example, okay? And it's a real one, and it tells you just exactly what can go on. This was $1 billion manufacturing facility, okay? And what was happening is the Windows displays said everything was fine, okay? And by the way, this article is in the November 2022 issue of IEEE Computer Magazine, okay? So what happened was, this doesn't at all sound like cybersecurity. The plant staff just didn't feel right about what they were seeing. So they decided, let's look at a different approach. So instead of just looking at the HMI, which would be the sensors going up,
Mm-hmm.
they said, let's look at the raw sensor signals. In other words, the physics, the actual, if you will, 4 to 20 milliamp current values. Okay. And we'll use machine learning. And ironically, this project was done about 2 to 3 months before ChatGPT came along. And it was using machine learning, and it was offline from both the IT and the OT networks. So you can't hack it, it's offline. It's just looking at the physics using machine learning. And we took one of the manufacturing lines. It had 16 sensors: pressure, temperature, flow, motor amperage, valve position, and vibration. This is the whole world. That's what everything is. And these are all different sensors from different companies. It's not like there's one company that, there was a problem with all of that. And what we found was more than half of those sensors were either inoperable or out of calibration. And the Windows HMI didn't show any of that.
Right.
Now, I'm saying that as somebody who came out of nuclear safety. This is very big. The second is they looked at the main feed pumps. This is what was critical to the productivity of this billion-dollar facility. And Windows said everything was fine with the pumps. But when you started looking at the raw sensor data, what you found were the pumps were having real problems, but with it seconds to less than a minute. It was too fast for Windows to see it. Windows said there was no problem with anything. Then what we did, which is part of the reason this is in IEEE Computer, did a really detailed cost impact study. Nobody's ever done this before. And what we found was that plant, that billion-dollar facility, was taking a 3% hit on net productivity every hour of every day. And oh, by the way, had no cybersecurity because you couldn't trust the sensors. Now, here is the other thing that made this so interesting. Because this project was called productivity, corporate was involved, plant management was involved, all of the plant staff was involved, as well as cyber. If this would have been called a cybersecurity project, the only people involved would have been the cyber people.
Wow.
What a message, isn't it?
Yeah,
Now,
that's interesting.
here is what happened and can be done. And people are fighting it tooth and nail. This goes to, fixing most all of these. I mean, ransomware can't get to it. I wrote a book. It's called Protecting Industrial Control Systems from Electronic Threats. I think you'd have to get it on Amazon. My original publisher, Momentum Press, I think is out of business, or somebody else has picked them up. I wrote it in 2010. It's still relevant. What a damning statement. Okay. My blog site is www.controlglobal.com/unfettered. I guess the other thing that's a kick is, do you know who Richard Clark is?
No.
Richard Clark was the cyber czar to about 3 different presidents. He was the one who wrote about, because he was Bush's, cyber czar and national security, trying to warn Bush about 9/11. And he wrote a book, Warnings, Finding Cassandras to Stop Catastrophes. I'll just give you just some of the things in the table of contents. This is not a cyber book. It talks about the invasion of Kuwait, Hurricane Katrina, the rise of ISIS, the Fukushima nuclear disaster, Madoff's Ponzi scheme, coal mine disasters. And that was, if you will, in the past. And then he goes forward. The book was actually published. What he was talking about in the future was artificial intelligence, pandemic disease, sea level rise, nuclear ice age, meteor strike, gene editing.
Oh, God.
And the only chapter in this entire book that's on cyber is chapter 14. It says, the engineer, the Internet of Everything. And that was me, by name. That's a kick.
That's funny. That's funny.
Thank you for listening to Amped Up. If you like this conversation, please support this content. Subscribe and rate the show on YouTube, Apple Podcast, or Spotify.